So hey guys, we have gotten to understand that titrations are a form of volumetric analysis used to determine the quantity or concentration of a solution using a standard solution. In this lesson, we will commence our discussion on acid-base titrations, which are used in the laboratories to determine the concentration of an unknown acid or base by reacting it with a standard solution of a base or acid respectively. Now, the idea here is, if I know the concentration of a base B, I can determine the concentration of an acid A by titration. Similarly, if I know the concentration of an acid A, I can determine the concentration of a base B by titration. To do this, we react the acid and base, find the volume of the unknown solution that reacts completely with the known solution, and then use the formula given in our lesson on mass and molar concentration to rationalize the molar concentration of the unknown solution. One might ask, how do we know when an acid completely reacts with a base? Well, we simply use an indicator. In our SS1 lesson on pH indicators, we agreed that an indicator is an organic dye added in small amounts to solutions, which visibly changes color due to changes in pH. These indicators tell us the endpoint of the neutralization reaction between the acid and the base. This table here shows us the two common indicators used during acid-base titrations, methyl orange and phenolphthalein, as well as their respective colors in acidic, basic, and neutral mediums. Now, since the endpoint of an acid-base titration should yield a neutral salt, we can determine the completion of an acid-base titration when the color of the solution corresponds to the color of the indicator in a neutral solution. See, all I'm saying is that the endpoint of an acid-base reaction using methyl orange would be when the solution is orange, while the endpoint of an acid-base reaction using phenolphthalein would be when the solution is colorless. Lastly, it is important to note when to use what indicator. Let's examine some titrations. Firstly, when titrating a strong acid and a strong base, like say hydrochloric acid and potassium hydroxide, we can use any indicator, be it methyl orange or phenolphthalein. Secondly, when titrating a strong acid and a weak base, like the titration between hydrochloric acid and sodium trioxocarbonate 4, we must use methyl orange. Thirdly, when titrating a weak acid and a strong base, like the titration between ethanoic acid and sodium hydroxide, we must use phenolphthalein. Finally, no indicator is suitable for the titration reaction between a weak acid like ethanoic acid and a weak base like sodium trioxocarbonate 4. And that's all for this lesson. Here are the key takeaways. Acid-base titrations are used to find the concentration of unknown solutions of acids or bases. Indicators are organic dyes added in small amounts to solutions which visibly changes color due to changes in pH. Methyl orange indicates an orange coloration at endpoints, while phenolphthalein is colorless at endpoints. The table here tells us the indicators suitable for different acid-base titrations.